So there are three conditions of continuity. So the first condition is it must be defined at that point. Okay, so the first one is it must be defined at that point. The second one is its limit its limit must exist at that point as well. So it must be defined at a point. Its limit must exist at that point. That means it must have a limit. And the value of the function at that point, and the value of a function at that point must equal the value of the limit at that point. In other words, 1 must equal 2. Point 1 must equal point 2. Okay, so the three conditions of continuity visually. What does this actually mean? Okay, so let's see if I have to actually draw this. We would have different scenarios of continuity where, let's suppose I've got three different graphs. Okay, let's say I get a few examples up here. Let's see if this makes sense. If I've got the first graph, which is, let's say, a cubic function that does that, okay, and I've got some point over here, let's call it A, then I can see that it's continuous at x is equal to A. Okay, this is my y-axis and this is my x-axis. Then I've got another graph which does this, but then it stops there and then continues that way. And that is at A. In this one here, we can see that f of A is not defined. So that means it has no x, it has no y value for A value. So in this case, it's not continuous because the y value doesn't exist, right? Then we got the case where if I stop with a solid circle and I start with an open circle, in another function, we can see that for this one, the limit as x tends to A, by the way, this is A, the limit is x tends to A of the function f of x. By the way, this is a piecewise function f of x. They both mean f of x. The limit does not exist. And why does that not exist? Because there's two possible values that y can be. So in this case here, we would say it's not continuous. And in the case where the function does something like the top one, but the dot is somewhere else, then in this case, we're saying that the limit as x tends to A of f of x is not equal to f of A. Because f of A actually lies over here, and the limit actually lies over here, right? As x tends to A. And in this case here, the limit doesn't exist. In this one, they're not equal. In this one, it's not defined. So let's go back there again. So the three rules are it must be defined at that point. like this one, it's defined. The limit, as the x values get closer and closer to a, exists. And the limit and the point at which it's defined is equal. So it fulfills all three criteria. In other words, a break or any kind of open circle would imply continuity stops. So continuity will not exist in those cases. Okay. So it has to be so continuous actually means continuous. Actually. It's almost like this one here, you're actually cutting the circuit out. So if you had water flowing, let's say pipe was flowing through. Let's say this was pipes. You have pipes and you have water flowing. This one, the water will go. Yeah. This one, the water will stop, will go back, will stop, go back, will never reach there. This one will go there, boom, and it will fall down. This one will go boom, it'll fall till there, then it will go sideways. So wherever it flows, it's continuous, right? And you can think of it like water.